So remember back when we were talking about woofs or whatever they're called by Gensler, we call them standard logical syntax. You know, those sorts of things, those 4 statements we seemingly always use. This is where we level up that part of things. This is where we talk about what we need to do to make proper categorical propositions. Now, a categorical proposition asserts that some or all of a class is denoted by its term. And so there are 4 categorical propositions: wholly inclusive, wholly exclusive, partially inclusive, and partially exclusive. But you know them as all no, some, and some are not. Now, when we put these 4 statements in standard logical form, we do so in the following way. You say all of a subject is a part of the predicate. No part of the subject term is a part of the predicate. Some of the subject term, that's not money, that's subject, is part of the predicate, and some of the subject term is not part of the predicate term, right? We'll use these terms predicate and subject term a lot from now on, so just familiarize yourself with them. So for technical reasons, we'll call these words all, no, some, and some are not. We'll call them quantifiers because they refer to the amount denoted in the term or in the proposition. And then words like is and are, we'll call them copulas because they join together the different terms. Now, when it comes to evaluating these kinds of propositions, we need some new terms to help us figure out a little bit more about these terms. The more we can describe about them, the more we know that the more that we know about how these kinds of propositions behave, the better we'll be able to understand quickly whether or not they're in proper logical form, and later on whether or not they are working in the correct way in larger arguments. We have 3 key terms that we have to talk about. The first is quality. And quality has to do with whether or not a term is affirmative or negative. Right? If it's affirmative, it's going to be an all or a some term. But if it's a negative, it's going to be a no and a some are not statement, right? Then we have quantity. And quantity has to do with whether or not a statement is universal or it is particular. All and no are universal, and you guessed it, some and some are not are particular. And the kinds of statements that these are is going to be really important later on. Now, the final bit we have to talk about is distribution. If you remember way back to the first week when we were talking about Gensler's star system, we had to talk about distribution. And I said just memorize what's distributed because otherwise you're going to get frustrated. And frankly, I just didn't want to tell you what it meant because I'm lazy. But distribution has to do with the amount of a class that is denoted by the kind of proposition it is. So let's look at the 4 kinds of statements that we're dealing with, and we'll be able to figure out why they are distributed the way they are and which terms are distributed. So if I said all tacos are delicious, right? I'm using an A statement, and an A statement says that every single taco, right? All tacos are delicious. All of this class is denoted by this statement. In other words, in an all statement, the subject term is distributed because taco here is the subject term, right? Now, why is the subject term and not the predicate term distributed? Well, tacos aren't the only thing that are delicious. You know, cinnamon rolls are also delicious. So, when it comes to no statements, let's say no sheep are wolves, right? What's distributed here? Well, no refers to the entirety of the class of sheep, and it refers to the entirety of the class of wolves. Thus, both the subject term and the predicate term are distributed in no statements. Now, when it comes to some statements, well, those are pretty straightforward. If I said, some pretzels make me thirsty, right? Does the sum refer to a certain amount of pretzels? Does it refer to a certain amount of things that make me thirsty? I don't know. And because I don't know, none of them are distributed. But when we get to some or not, let's say some pretzels do not make me thirsty. Well, what's distributed? Well, because it's a sum statement, I know that the sum part of it doesn't pertain to either side of this in the same way that it would if it was a no or an all statement, right? However, not thirsty. The not here refers to all of the class of things that would make me thirsty. Thus, this term here is distributed. The predicate term is distributed, whereas the subject term is not. All right, so I've just thrown a ton of information at you, and you're probably going, man, how do I organize all of this? Well, luckily, some old dudes in the medieval times decided that they would represent all of these kinds of statements with letters. They chose vowels. And then they would even organize those vowels in a particular way called the modern square of opposition that allows us to see elements like quality, quantity, and, the relation between the two. So, all statements are called A statements. No statements are called E statements. Then you guessed it, some statements are called I statements, and some are not statements are called O statements. Now, with these 4 letters, we can then determine a great deal about the relationship between them. So for example, these right here, these are universal. So in terms of quality or quantity, they are universal. And these are particular. But these across here like this, these are affirmative in terms of quality. And these are negative. Now, here's where it gets interesting. We also have contradictory statements. And these are on diagonals from one another. So, if I were to say, all emo bands are full of sad boys, I can't also say, some emo bands are not full of sad boys. Because only one of those can be correct. They are logical contradictions. The answer being, the O statement is correct, because Rainer Maria is an emo band with non-boys in it. So there you go. You've got your modern square of opposition. You've got your rules for distribution. You know which ones those are. And next week we're going to figure out what all of this has to do with evaluating the validity or invalidity of categorical syllogisms.
Rainer Maria is like the most inside baseball emoji ever.